Hi all, this is Dr. Ford. So this is a continuation from the configuring of variables in the survey data set. So I've set up the regression analysis and I've already put information in. So as you can see, we used the dependent variable with stress. We used all the variables that we had identified. Notice that when you're moving your variables to this section, you have anything that you have that's continuous would go here, and then the other factors here. So I have the results that I output. I'll scroll down and show you what I checked. We've got our fit measures for our linear regression model, our plots, normality, collinearity, and then we wanted our standard estimate with a confidence interval of 95%. So what I'm going to do now is this is going to be a really interesting teaching moment. So I have my results here that you saw in Jamovi, but now I have them in Word, so it's easy enough, and I've added a little bit of interpretation. So based on our R-square, the model explains less than 1% of the variance in stress scores. So all of the variables that we chose, let me scroll up here, that we chose that we thought, okay, maybe it has to do with their commute, or how much they exercise, or how much they sleep, or their age, and then, all the variables that we chose. We found that based on my linear regression model, that only 1% of the variance is explained in this model. It's very, very small. And our sample size was 3,025 records. So I've got my predictors here. So we got a couple of two significant predictors, okay? So age, we've got a p-value of 0.038. Older employees report slightly lower stress levels. It is statistically significant, even though it's small. And of course, a lot of times if you're older, you can manage stress better, or coping. That doesn't necessarily mean it's true, but that's one of our significant predictors. And then the folks who work overtime, a p-value of 0.053. Employees who work overtime tend to have a slightly higher stress score, and it is marginally significant. So we could look at it or explore it further, even though it kind of misses the 0.05 threshold of the confidence level. So non-significant predictors, gender had nothing to do with it, their job level, department, employee type, and then their hours that they spend either sleeping, exercising, or commuting. So even though we think these might be relevant, they showed no statistical influence. Now, maybe this company has like the best work-life balance ever, and therefore this is not telling us what we are thinking. What I originally thought when I wrote the research question is there's got to be something that influences stress. So again, it could be that this company that the data was collected from really, really does a great job with their employees. I'm not sure yet. But this is one of the downfalls, and that's what I wanted to share with you. I wanted to share this because this is certainly a teaching moment. I know when I went through my dissertation, I absolutely knew that my hypotheses, my null hypotheses would be rejected, but that's not the case. So anyway, that doesn't mean you throw your research out the window. You just report it as it is. But I ran assumption checks with a p-value, and this is the residual plots I've got down here, but the model is statistically valid, so I didn't do anything that when building the model, I didn't violate any rules. And then, so anyway, so stress is measured on a Likert scale. And so that is not surprising. Some people, again, it could be, it could be that if you talk to people about their stress levels, that you might find out. So this might be a good opportunity to, instead of using a Likert score for the stress level, that you actually supplement this with some qualitative data. So here are all my plots that I did, and here's my summary analysis. And I kind of wrote it like you'd write a dissertation, because again, you don't always want to throw something out the window, especially if you spent the time validating your survey instrument and then, you know, finding or getting people to respond and so forth. So it is saying that my model is statistically significant, but it only accounted for a small portion of stress scores. Age was found to be statistically significant with older employees reporting slightly lower stress levels. And then, of course, overtime, as I showed earlier. And so anyway, we cannot reject our null hypothesis, which is that these variables do not significantly predict stress level. Again, we cannot reject that. So what does this mean? Just because we fail to reject the null hypothesis doesn't mean that null is true. It just means, based on the evidence that we collected from the surveys, that we didn't have enough to support the alternative. So anyway, again, in this case, the demographic, organizational, and lifestyle factors that I chose, the variables I chose, don't significantly predict stress levels in this data set. And again, I don't know which company that this was gathered from. Shoot, I don't even know if it's actually, you know, real data, because I got it from Kaggle. I would hope it was. I can't imagine somebody building that much synthetic data. But anyway, I just wanted to show you that just because you cannot reject your null hypothesis doesn't mean that your research is not valid. It just means that maybe the way you, maybe what was collected in the survey had nothing to do with, you know, with predicting stress. It could potentially be that this is like one of the best companies in the world to work for, so therefore stress levels are not high. There could be all kinds of factors that influence it. So anyway, this is the end of the second half, where I did a different type of model in Jamovi, where we really dug into more predictor variables than just one dependent and one predictor.